Integrating with API Gateway. We'll now discuss integrating an API method with a Lambda function by using Lambda proxy integration or Lambda non-proxy, which is a custom integration. API Gateway wraps client requests with metadata that Lambda needs and passes the wrapped request to the target function. The response is handled differently depending on whether you choose a non-proxy or proxy integration between API Gateway and Lambda. In Lambda non-proxy integration, when the client makes a request, the API Gateway is able to transform it and then forward it to Lambda. Similarly, when the response data comes from the Lambda function to the API Gateway, it sets the header, status code, and other information. In Lambda proxy integration, when the client makes a request, the API Gateway forwards the request to Lambda without transforming. The Lambda function parses the request data itself and handles the response. Suppose that you have an API that only needs to forward HTTP requests to a Lambda function that can respond to the client. Setting up a proxy integration is simpler than setting up a direct integration, but your Lambda function must handle creation of an appropriate response. Use non-proxy integrations to have API Gateway wrap the response for use by an HTTP client. You can also use custom integrations when you must transform the Lambda response in some way before returning it to the client. This example shows a non-proxy or custom integration between API Gateway and a Lambda function. Note that a JSON response from the Lambda function is set up by using the Lambda console to test the function. API Gateway automatically wraps that message to make it a valid response for a browser or client that understands HTTP. It uses the structure that is illustrated on the slide. The response includes the 200 status code to indicate a successful response. Now, we'll look at an example of a Lambda error response in proxy integration. Sometimes, even though the call is successful, you might want to pass error information back to the client rather than returning a 200 OK status. In this example, your Lambda function returns a 403 error with the message that the request has a permissions issue. This call to the API is successful, so API Gateway would treat the call as a 200 OK response. However, what is important to your client is that the request has a permissions issue. To handle function errors that you want to return to the client with a non-proxy integration, map the response errors to standard HTTP error responses. In this way, your clients don't receive the response as a 200 status. With a Lambda proxy integration, you use the output format that API Gateway requires. Include the error information as part of your customized Lambda response as illustrated on the slide. When you choose a non-proxy integration with Lambda, API Gateway can modify or enrich the request or the response, rather than merely wrapping it. You can use API Gateway mapping templates, which are written in Apache Velocity Template Language, or VTL, to transform requests. In other words, you can use the mapping template to translate the data from one model to another. For example, you might use mapping to delete, add, or edit parameters. By using this method, you don't need to write your Lambda response so that a browser understands it. You also gain more control over the response that was returned to the client. You can let the Lambda function return JSON. You can use mapping template VTL to modify the response to include the formatting and status codes that the client needs. You can also use mapping templates to handle custom errors. An API's method request can take a payload in a different format from the corresponding integration request payload, as required in the backend. Similarly, the backend may return an integration response payload different from the method response payload as expected by the front end. You can use mapping templates to map the payload from a method request to the corresponding integration request, and from an integration response to the corresponding method response. This example uses VTL to map some of the data on the incoming request to the format that the backend requires. For example, the first and last name are combined into name, The city and state become part of an address element, and the favorite pizza is changed from pineapple to Hawaiian. In this example, the Lambda function returns a simple JSON message, and the mapping template transforms it for use by a browser. Thanks for watching. We'll see you in the next video. Integrating with API Gateway. You can integrate your HTTP API with AWS services by using first-class integrations. A first-class integration connects an HTTP API route to an AWS service API. When a client invokes a route that's backed by a first-class integration, API Gateway invokes an AWS service API for you. For example, you can use first-class integrations to send a message to an Amazon Simple Queue service or Amazon SQS queue, or to start a step function state machine. First-class integrations have required and optional parameters. You must configure all required parameters to create an integration. You can use static values or map parameters that are dynamically evaluated at runtime. To create a first-class integration, choose a supported AWS service action, such as SQS send message. Configure the request parameters, and provide a role that grants API Gateway permissions to invoke the integrated AWS Services API. Depending on the integration subtype, different request parameters are required. This slide displays an AWS CLI command to create an integration that sends an Amazon SQS message. The queue URL and message value in the request body are forwarded to Amazon SQS to process. When you use the console to work with an AWS service, it cannot know which mappings your application is using. Therefore, you must set up the request parameters. An HTTP proxy integration enables you to connect an API route to a publicly routable HTTP endpoint. With this integration type, API Gateway passes the entire request and response between the front end and the back end. This method is useful when migrating from a monolithic application to web services. You can map your entire monolith with API Gateway routes and forward them to your monolith's endpoints. Then, one by one, you can remap specific routes to point to your new Lambda function services as you break off pieces of the monolith. In the slide example, in step 1, you start with 2 API routes that connect to a monolithic application on Amazon EC2. In step 2, you point the /services route API gateway and use an HTTP proxy integration to point it back to your monolith endpoint on Amazon EC2. Finally, when your updated version of the /services service is written in a Lambda function, you point the API integration to the Lambda function instead. With a private integration, you can expose your HTTP or HTTPS resources within an Amazon VPC for clients outside of the VPC to access. You can control access to your API by using any of the authorization methods that API Gateway supports. To create a private integration, you must first create a network load balancer. It must have a listener that routes requests to resources in your VPC. Then, create a VPC link to connect your API and your network load balancer. After creating the VPC link, create private integrations to route traffic from your API to resources in your VPC through your VPC link and network load balancer. This slide provides an example of how to create a private integration. It assumes that you've created your VPC link, then use the create integration method to connect API Gateway to VPC resources by using the VPC link. Now, we'll look at how to modify API requests from clients before they reach your backend integrations. As illustrated in the Lambda non-proxy integration example, you can modify API requests from clients before they reach your backend integrations. You can also change the response from integrations before API Gateway returns the response to the clients. You can use parameter mapping to modify API requests and responses for HTTP APIs. To use parameter mapping, you specify API requests or response parameters to modify, and then specify how to modify those parameters. Note that you cannot configure requests or response mappings for reserved headers. This slide shows an example of how to request transformation. You can append, overwrite, or remove any header value that you choose. You can also do these tasks for query string values, and you can override entire paths. Request parameters are a key value map. The key identifies the location of the request parameter to change and how to change it. The value specifies the new data for the parameter. The example adds a header named header1 to an API request before it reaches your backend integration. And API Gateway populates the header with the request ID. Here are the key takeaways for this section of the module. API Gateway simplifies the work to integrate with AWS services from your client applications. Use Lambda proxy and HTTP proxy integrations for simple pass-throughs to backend services. And use transformation options to modify requests and responses between clients and targets. Thanks for watching. We'll see you in the next video. Deploying an API. After you create your API, you must deploy it before users can call it. To deploy an API, you create an API deployment and associate it with a stage. Stages are meant to help with the development lifecycle of an API. For example, when you first build your API, you deploy it to a development stage. When you're ready for production, you can then deploy it to a production stage. You must select a stage when deploying a REST or WebSocket API. An HTTP API deploys to a default stage when you create it, to make it simpler for you to deploy. You can set any stage in an HTTP API to auto-deploy. You can use a stage to manage and optimize a particular deployment. For example, you can set up stage settings to enable caching, customize request throttling, or configure logging. You can use stage variables to connect different API stages to different versions of a backend. For example, 2 different Lambda function versions. As mentioned earlier, one use case for stages is to differentiate API versions between development and production. Using a dynamic AJAX-based website as the example client, you could deploy the API in a production stage connected to a production Lambda function. Then, continue to improve the code in another version of the Lambda function and test it by using the dev stage of the API. When you create a deployment, you instantiate the deployment resource. The deployment is an immutable representation of a REST API resource that users can call by using stages. A deployment must be associated with a stage before it can be called over the internet. You can use the API Gateway Console, the AWS CLI, an AWS SDK, or the API Gateway REST API to create a deployment. When using an API Gateway, you create stages, such as development, QA, and production. You might want to call different aliases of the same Lambda function for different stages you've created. You can do that with stage variables. With stage-level variables, you can set variables that are different per stage. This technique helps developers target different resources. For example, pointing to a development database rather than the production database, without writing different code. Continuing the dynamic website example, you can use API Gateway stage variables to programmatically tie different API versions to different versions of your Lambda functions. You can use Lambda aliases as the stage variable values. You'll learn more about Lambda aliases later in this course. Modern applications frequently deploy updates to implement new features. But updating or changing a production application is often risky and might introduce bugs. Canary deployments are a popular strategy to help mitigate this risk. In a canary deployment, you partially deploy a new software feature and shift some percentage of traffic to a new version of the application. This allows you to verify stability and reduce risk associated with the new release. After gaining confidence in the new version, you can continually increment traffic until all traffic flows to the new release. Additionally, a canary deployment can be a cost-effective approach because you don't need to duplicate application resources, compared with other deployment strategies such as blue-green deployments. To deploy an API with a canary release, create a canary release deployment by adding canary settings to the stage of a regular deployment. The canary settings describe the underlying canary release, and the stage represents the production release of the API within this deployment. API Gateway handles sending the traffic to the canary on your specified stage. This strategy is a good way to catch issues and minimize any impact to most of the API users. The code excerpt on this slide is part of a deployment that uses a canary to send 10.5% of traffic to the canary. If the results of the canary testing are successful, increase the percentage of traffic that goes to the canary. You can also enable or disable the use of a staging cache to optimize the test performance. You can also modify stage variables used in the canary release when the execution context is updated. Continue to monitor the result to ensure that nothing unexpected happens. Continue updating the percentage until you're ready to promote the canary version to the production version. When you promote the canary, the stage is fully deployed to production. Here are the key takeaways for this section of the module. Stages are snapshots of an API version and are required to deploy your API. You can use stages to differentiate deployments for different development environments or backends. And use canary deployments to test out an API by sending a percentage of traffic to a new version. Thanks for watching. We'll see you in the next video. 7 Part 1. Controlling access to a REST API. We'll now discuss how API Gateway provides a number of ways to protect your API from certain threats, such as malicious users or spikes in traffic. We'll start with AWS Identity and Access Management, or IAM, resource policies. With REST APIs, you can use AWS resource policies to control access to your API's endpoint without using other services like AWS WAF. Amazon API Gateway resource policies are JSON policy documents that you attach to an API. The policy controls whether a specified principal, typically an IAM user or role, can invoke the API. For example, you might use IAM permissions to allow users in a different AWS account to access your API. Alternatively, you might limit access to your API's dev stage to only people in your office by using the IP address of the office network. HTTP APIs currently cannot use resource policies in this way. Custom domain names are simple and intuitive URLs that you can provide to your API users. With a custom domain, users feel confident that they are providing their credentials to the right party. With so many fraudulent sites on the internet these days, it's not surprising that people are wary of clicking on a URL they don't recognize. Using a custom domain that is clearly connected to your business can encourage customer trust. To support the use of certificates as a method of controlling access to your APIs, you first set up a custom domain for your API. After your custom domain is set up, you can set up your certificate. When the certificate is set up, your EC2 instances can confirm that a request came in from API Gateway. You can generate client-side SSL certificates in API Gateway and use the public key to verify that HTTP requests to your backend systems originated from API Gateway. API Gateway can generate SSL certificates, so you can use the public key of the certificate in your backend to authenticate API requests from API Gateway. This allows you to control and accept only requests originating from API Gateway, even if your HTTP backend is publicly accessible. You can install certificates on devices such as IoT devices, Then API Gateway can ensure that they are valid when their requests come in. The process uses SSL, or more specifically TLS. Even more specifically, it would be mutual TLS because both API Gateway and the IoT device have a certificate. This mutual TLS is possible only when using a custom domain with your API Gateway. In that way, your API has a certificate that your IoT device can confirm. The client certificate generated by API Gateway is valid for 365 days. You must rotate the certificate before a client certificate on an API stage expires to avoid any downtime for the API. AWS WAF is a managed web application firewall that can be used in conjunction with API Gateway regional endpoints with or without customer-managed CloudFront distributions. You can deploy AWS WAF on CloudFront as part of your Content Delivery Network, or CDN, solution, or on API Gateway for your APIs. You can use managed rules, which are pre-configured sets of rules to address common security risks. These rules are regularly updated. With AWS WAF, you can protect APIs from common web exploits like SQL injection and cross-site scripting. You can also match specified string or regular expression patterns in HTTP headers, methods, query strings, URIs, and the request body. You can also block requests based on their origin from specified IP address ranges, a specific country or region, or specific user agents, bad bots, and content scrapers. Thanks for watching. We'll see you in the next video. 2. Controlling access to a REST API. Cross-origin resource sharing, or CORS, is a browser security feature that restricts cross-origin HTTP requests that are initiated from scripts that run in the browser. It defines a way for client web applications that are loaded in one domain to interact with resources in another domain. The browser enforces CORS, which is relevant to you only if your clients are browsers. If your API will receive cross-origin requests, you should enable CORS support. With CORS support, you can accept requests that you want while preventing cross-origin requests to domains that don't explicitly allow the originating domain or origin. A cross-origin HTTP request can be made to a different domain. For example, from example.com to amazondomains.com. It could be made to a different subdomain. For example, from example.com to petstore.example.com. A cross-origin HTTP request could also be made to a different port, such as from example.com to example.com:10777, or a different protocol, such as from HTTPS example.com to HTTP example.com. Web-based applications that are dynamic and thus make AJAX requests to servers will likely run into CORS at some point. For example, suppose that a web application is served from an Amazon S3 bucket. You have API Gateway running in front of a Lambda function to get products from DynamoDB. Then, the browser will block the request to DynamoDB as a cross-origin request. The browser knows which domain it is on, for example, abc.example.com. When it makes AJAX requests to anything in that same domain, such as abc.example.com/products, CORS support is not required. However, your web application might make a non-simple AJAX request that is cross-domain, such as xyz.example.com or abc.somethirdparty.com. In this case, the browser thinks that you are at one site and another unknown, untrusted site is trying to inject data into your web page. As a result, the browser prevents the action. To allow these types of requests, CORS requires a pre-flight request that uses the options method to find out which methods are allowed. If the type of request that is specified in the pre-flight request is approved, then the actual request gets sent. That call has a time to live, or TTL setting, which you configure. When you enable CORS for your API, You specify a list of allowed headers, methods, and origins that might access the resource. They're used in response to the pre-flight request. Requests that do not meet the criteria for the allowed headers, methods, and origins will generate an error. Notice that simple AJAX requests, such as GETs, are generally read-only. In other words, they're not writing anything to a server or database. They are considered simple requests that do not require core support. Sites that are frequently consumed, such as Twitter, now require API dev keys via post. Thus, they are not simple requests. So the browser will use CORS protection for any requests. At one time, these APIs allowed GET requests from anyone, but they no longer do so. CORS headers can be configured on an API gateway to direct API clients to only invoke API calls from allowed origins. CORS enables clients from one domain or origin to invoke API methods from another domain. CORS also prevents cross-origin requests to domains that do not explicitly allow the originating domain or origin. API Gateway can be set up as a proxy to handle all the pre-flight request options work. Therefore, you don't need to manage that part of the server. Using API Gateway with Lambda means that you have less code to write to be able to handle CORS inside your Lambda code. You can enable and configure CORS on both REST and HTTP APIs. When you configure CORS for a REST API, API Gateway sets up a mock endpoint to handle the options method. The setup is simplified when using HTTP APIs. Thanks for watching. We'll see you in the next video. Section 7, Part 3, Controlling Access to a REST API. Another way to protect your API is to throttle requests to prevent it from being overwhelmed by too many requests. Throttling helps to protect your APIs from rate-based attacks, and API Gateway APIs share a region-wide quota of 10,000 requests per second. You can also set quotas per API on individual methods and by client to manage the volume of requests that hit your APIs. If you receive a 429 too many requests error in response to an API Gateway request, it is an indication that the request was throttled. You can set throttling rates per stage or per method for REST APIs, or routes for HTTP APIs. A usage plan specifies who can access deployed stages and methods, and controls the rate and number of requests that a client makes. Within usage plans, you can set throttling limits to control the request rate. You also can set a quota to control how many requests an API key can use within a specific time frame. API keys are unique string values that you give out to grant access to APIs. You can set the default method throttling to override the account leveling request throttling limits for a specific stage or for individual methods in your API. The default method throttling limits are bounded by the account level rate limits, even if you set the default method throttling limits higher than the account level limits. Settings are applied first to the most granular control. For example, suppose that an incoming request is from a client tied to a usage plan on a REST API. Throttling related to individual methods for that client is applied first, followed by any client-level limits. Next, any throttling settings indicated for a particular method and stage are applied, followed by any limits placed across the entire stage. Finally, if no throttling is applied at more granular levels, the account quota is applied. Thanks for watching. We'll see you in the next video.